So hello everyone, welcome to my video. So today I will be showcasing an innovative project called Auto Threshold for AI ML models. This project is a leap forward in learning artificial intelligence and machine learning to advance the fraud detection system. We will explore how dynamic threshold works and how it enhances adaptability and reduce false positives. So for those who know who don't know about dynamic threshold is not a fixed value. It adjusts based on the patterns of current data. So by adding to current data, dynamic threshold can reduce false positives and false negatives. And you can see what are the highlights. You can just see on the presentation window. Auto thresholds that are single or multiple auto thresholds. These are highlights by using functions like mean, median, mode, standard deviation, quantile, or shell out a score. These all are functions and formulas that we will use in data science. So we will use that also. Also, you can see that auto threshold use cases are rule based or AIML based alerts. We will apply these auto threshold on both rule based alerts or and also artificial or ML based alerts, and even to clustering report as well. Last time I showed k-means clustering, so we will automate the k-mean clustering through Charlotte score, so that it will be automatic thresholds will be given and the reports will be generated accordingly. Then it's scenario testing for every threshold technique. I will explain it in a very easy manner ahead. Also, you can see the last is the very high level artificial intelligence setup, what which compromises not of these auto threshold based on these functions like mean, median, mode, standard deviation, quantile, or silhouette score, but this is system based. This is an artificial intelligence based auto threshold, as I told you, dynamic threshold based on patterns, based on incoming data. So it will, the system will decide accordingly. So you can see the highlight fully automated AI based fraud alert generation. So what happen what will happen is that system will as per the data, system will check if it is fraudulent, and if the alert should be generated, then the one model, stacked model, will generate the alert, and another stacked model in which artificial intelligence and machine learning both are used, it will give the prediction about what type of data fraud it is. So basically two models will be used simultaneously for the single data, I mean for the incoming data. So that's why it's a very high level engineering and very high level artificial intelligence setup plus predictions. So I named it as fully automated AI based fraud alert generation. Okay, so that's it from the presentation slide. We will move to next slide now. Okay, so here we are on the slide of introduction to auto threshold of AI ML models. So yeah, let's start by understanding the key techniques. I mean, firstly, I will read out the points. An advanced AIML fraud detection project. What is the objective? Automating the threshold selection for fraud detection. Key features are that it will eliminates manual intervention. No manual intervention is being done. We don't have to check, what is the highest probabilities or what are the adjust the false positive and false negative, what how we revise the fraud probabilities or thresholds or values or scores, whatever you use in alert generation. So basically, firstly, it eliminates that manual intervention. Then it enhances model adaptability with real-time data. Okay, the data is coming and model itself is adjusting the thresholds and as per fraud data or whatever the use case and the patterns. So it will help significantly reducing the false alerts with identifying critical cases. So as you can see on the presentation window, this picture is showing that firstly the data is there, then model is doing threshold calculation is being done, and then model will take the decision. So this is whole totally automatic based. That is the last highlight of this project. Before that we will learn basic automatic auto threshold techniques also. So let's move to next slide. Okay. Okay, so here are we on next slides, and the title is key techniques for setting auto thresholds. Okay, so let's start by understanding the key techniques used for thresholding. The project incorporates various statistical methods, including mean. And what is mean? It is the average value of data points. You can see median, the middle value that splits data into two equal halves. Then it is mode, the most frequent occurring value in the data set. I will explain this also. Quantile. Quantile is like, it is based on percentile based thresholds. For example, I have written top 2% means, top 2% of the fraudulent, records. Or in banking, you can say fraudulent transactions. We want to generate alerts. Okay, so each method adapts to data distribution for optimal performance, and this is something box plot chart I have shown. Let me tell you with the examples. So, firstly, we will see what is mean. So, for the given sample of data, you can see the data in chart as well. The sample data, also the whole data is in the left side of the slide. So what is the mean? Average. So average is, you can see here on the chart on the right side, mean is 14.45, also with the red line highlighted. Okay. So means middle value. Means average of all the data points. Then median is the middle value of all the data points, that is 14. Okay. So in the left side also you can see the number starting from double a 8 8 9 9 9 10 10. So median is the middle value of all the numbers. Okay. So it is 14. If I okay, so that is the 14. Then mode is, I told you, most frequent number. So you can see maximum time, which number has been occurred. I mean, if we see number starting with 8, 8 is happening two times, then 9 is happening three times, then 10 is happening two times again, then 14 is happening two times again. Then you can see all the numbers are unique. So we have our modes, most frequently occurring value. Because we have not given any, we can take the 9 and 10 as well, and 14 as well, given with the in the condition of mode, which mode it is the first occurring mode, so that's why it is 8. You can take the second occurring as well, third occurring as well. It's up to you. So by default, most occurring number is 8, so mode is 8. Then I will tell you about quantile. That is, I already told you, percentile based. So you can see here, in a box plot chart, the blue rectangular data. So first one is highlighted in here, quarter one, quantile 1, sorry, 10.0, and quantile 3, 17.25. So this is our first quantile, which is starting from 10. And okay, so then there is a middle value also with the median value also, and means the middle value median 14 with the blue line you can see here. So this is our second quantile, and third quantile that is ending with the blue data, that is 17.25. You can use them also, this also. Yeah, whether you want quantile value, first one 25%, 50%, or 75% accordingly. So okay, then this is with this slide. We will move to next slide now. Okay, so here we are. So these are the use cases for this technique in fraud detection. I mean mean, median, mode, quantile, that I just explained. So these are two rules. P1 generated a generative AI generated fraud record greater than equal to 5 detected, and the other one is P1 high generative AI generated fraud records detected. So this is the sample alert you are watching on the presentation screen. You can see here it is based on destination, so it will uh, fire on destination wise, and I will show you now how it works. Okay. Okay, so let's discuss these use cases in detail now. As I told you, we will apply the auto threshold functions that I discussed on these two rules. So let me go to the production environment, and okay, as you can see here, so this is destination wise auto threshold using mean, median, standard deviation, and quantile, and this is a single threshold base. So as you can see, the model file is the that I used in a earlier video also, that was made for generative AI. My generative AI model file, just I have use the same training data and transform into my generative AI model slash underscore n, so that I can use in this environment. So what happening is same. We are spooling the data from SQL Server from this query. Then we are transforming the data as per our model and requirement, and then some feature engineering also for overlapping call and all. And similarly, the thing start from here. You can see here probabilities are being added to the data frame, and then what happening is now these functions, average, mean, I told you mean, and then standard deviation, and then median, and then upper quantile, that will be used, and the threshold will be calculated on these basis. And this will be a dynamic threshold, as I told you. So some adjustment has been done to for this probability, uh, to this probability to use according to our business requirement. I will explain. We will first go to the output window. I will run this code again in front of you live, but firstly we have to understand this from which part, from this part. You can see here last time this code ran. So the mean probability for the fraud records was 0.46, I mean for this data set. Then standard deviation was 0.35, median was 0.32, and the upper quantile was 0.91. Okay. So what happened is, you can see here the last line, processing with auto assigned threshold 0.81. So you must be asking where that come from. I mean, 81. How the probability is for probability, the threshold becomes 81. So I will explain this. Let me explain this to you. Okay, so before explaining these stats, I will firstly explain the standard deviation, which was left last time, because I have not written in this in this details, highlighted points. I mean, so let me discuss the standard deviation in our use case of threshold or auto threshold. So, what is standard deviation? You can see here also in this. If I now you can see in presentation window that already this bar chart is box plot chart is showing that standard deviation is 5.16. You can see here for these values in the left bottom. This is the standard deviation 5.16. Okay. So what is standard deviation? This is the measure of amount of variation in the values. So this deviation of 5.16 uh, means that the values are typically vary from 5.55% something from the average of 14.45. Okay. So in summary, you can understand that what is standard deviation. It shows the variation in the values. Yeah. So a standard deviation. here of 5.16 shows that means that the values are typically varied by 5% something from the average, that is from the mean, I mean, that is 14.45. So this gives an idea of the range where our most of the values lies. I will tell you how. You can see. So you can see I have added the standard deviation of 5.16 in average. You can see in this, x-axis as well. If we add 14.45 plus 1 5.16 mean plus standard deviation, it becomes 19.61. I have highlighted that in x-axis here near to 20. And if I minus standard deviation from mean, it becomes 9.29. So it becomes here, I have shown in an axis also. It's nearby to 10. So from 9.29 to 9.61 becomes the range where most of the our value lies. So this is not I haven't made up. This is thumb rule called empirical rule in data science. So now you've got a broader idea that the our most of the our values lies between 9 point this range 9.29 till 19.61. Okay. So this is this formula is according to Gaussian distribution, and similarly, this covers the 68% of the data lies between 9.29 plus 2 to 19.61. And similarly, if we double the standard deviation, then the data become 95%, and if we triple the standard deviation, the data become 99.7%. Okay, so yeah, we are here in our use case uh, of auto threshold for the that rule that we have just checked. So I will explain this. The average value of 0.46 here, this is the average probability values across our data set. uh, it means that on average basis, the probability of records that we are analyzing is 46%. All right, so what about median? Median is 0.32. So the median is the middle value, as I told you before, and this is the middle value of the probabilities if are sorted in ascending order. So in our context, these fraud records, it means that the probability values of 32% are below 50% and 32% are above 50%. Okay, so you can say that it's a middle value. 32% means the data is still 32% above this. Okay, and 32% also is probabilities are below this, means this is the middle value of fraud probability is 0.32. Now you got that. Okay, so let me tell about this upper quantile, and you can see in presentation window, and also I showed this is just the copy of that data set, the code I ran, the output. So the upper quantile is value is 0.91. You can I have already told you this upper quantile was set on 75%. So this is the top 25% probability values. So yeah, so it means that the 25% values, I mean 25% of probabilities in our records is above 0.91 simply. Okay, so yeah, so let me explain now the this also the standard deviation of 0.35 in this our use case. I explained you just before this, and so here it means that a standard deviation of 0.35, the probability sorry, the probability values typically vary from 35% from the average of 46%. This gives an idea of the range where, as I told you before, where our most of the probabilities lies. And similarly, I have added. You can see here 0.46 plus 0.35 becomes 0.81, and if I minus 0.35, it becomes 0.11. So from 11% to 81% is the range wherever 68% of the data lies. Okay, as per this empirical rule of Gaussian distribution. Okay, okay. Okay, all right. But I will give you a very simple explanation. Also, you can see in this box plot chart, this blue value is starting from which point? This one is quantile one. The median is the quantile two, and 0.91 value is quantile three that we have taken. So you can understand that now that 32% is the median value. So above that also 32% probability lies, and 32% lies below that, I mean behind that. You can see this blue is all the data of from quantile 1 till quantile 2 till quantile 3, which is 0.91. So we have taken the 75% quantile. So this is the value of probability 0.91 over that. So that's why we have take this is the quantile 3. So it doesn't mean that it will the probabilities will end here. The probabilities are till 100%, I have showed in the arrow. Okay, so I will tell you that what happens is why we are taking standard deviation into this, because standard deviation will tell you the data is evenly distributed or highly uneven. So if a standard deviation is very small, I mean relative, nearby to the mean, it suggests that probability values are evenly distributed, are around the average, around the mean. And if it is larger standard deviation, indicates that the probability values are more spread out, and suggesting that the distribution is very uneven. Okay, so in our case, we can say that a standard deviation of 35% suggests a moderate spread around the mean, because you can see now that average is 46% and standard deviation is 35%. So it is around the mean. So while there is some variation, we can see that it is not excessively high. So this what happens is that this helps in understanding the reliability and consistency of the probability values in our data set. And let me discuss about the formula now that we have applied. Okay, so here is the formula. So as you can see, if standard probability, in our case it's 35%, 0.35. So if standard probability is less than 20%, so it means I am treating this value of 20% as low variance. So what is 20%? I mean logically of 100% is low. You can you can change, you can take any value as per your business requirement. So if the value is less than 20%, so what will happen? It will take the upper quantile. In our case, it's 0.91. So the threshold will become 0.91 if the standard deviation is less than 20%. Less than 20%, I am treating it as very low variance. As I told you earlier that our fraud probability is 0.35 in our fraud records. It's moderate. So else it means if it is greater than 0.2%, I mean greater than 20%, then use this formula. Use mean plus standard deviation. So mean probability is in our case is 0.45 plus standard deviation is 0.35. So if we add this, it becomes 0.81. That why it was showing the processing with auto threshold equal to 0.81%. So what happens is you can understand now very easily that what I have done when the deviation is low. I mean, if you're treating that if the deviation is less than 20%, I'm treating it as low. Then set the upper quantile, which is for our case is 0.91. So 91 becomes the threshold. So why? Because this approach, in with this approach we adjusted the threshold upwards. Okay, so what happened is when when we know that standard deviation is not making much effect on data, so why not take the upper quantile, that is the higher fraud probability records. So similarly, when the variance is high, I mean greater than 20%, then use mean plus standard deviation. So in our case, mean was zero point 0.5 and standard deviation was zero point 0.5. That's why the threshold becomes 0.81. So in the case of high variance, because in high variance we are assuming that the values are widely spread. So using mean and adding it to standard deviation helps to capture the deviation from the mean. Whatever the significant deviations are from the mean, it will help us to catch that. So this is very simple and very strong formula in data science to use as a dynamic adjustment. Okay, and you can periodically review and fine tune the threshold based on the feedback, and further evolve this. You can further evolve the this formula also. Okay. Okay, so let me show you the last part of this. I will explain this with this chart also. This is the probability distribution with all the functions that we have used. So simply first understand that this blue line, clear blue line, is our mean. Okay, and then you can see this is our median. This yellow dotted yellow line is our median middle value, and blue, I as already told, is mean. And you can see here uh, the upper quantile that I was telling you is 0.91. Is this one is that a red dot line. So and our range, that is if you minus standard deviation from the mean, it is still green line, and if we add standard deviation to the mean, to the blue line I mean, then it becomes our this one purple line. This is the auto threshold that we have taken. So you can understand that these blue bars in behind, sky blue bars, that is the probability distribution uh, in a of of our records. And you can understand that most values are clustered around the mean. So if you see the shaded region, you can see that it is it is standard deviation in the data. Wider shading means higher variance. Okay, so threshold logic I already told you. So if I, yeah, this is the shaded region, you can see here, this this here, because this is our average blue line, and minus standard deviation till green line, plus standard deviation towards the purple line. So if variance is low, then what happens if you tend towards the green? If low, it means if the variance is going towards the green, then model prioritize the upper quantile. So at that condition, on that condition, the this upper quantile, it means red line, will become the auto threshold of 0.91. But the thing is that if the variance is high, because in our case, so what happens is that mean plus standard deviation. So mean 0.46 plus standard deviation, that was 0.35. So that's why the I mean this purple line becomes the threshold in our case. This is called upper bound, and this is called lower bound in case of the range. Okay, I believe that this is a very easy and effective way of understanding these probability distribution. Okay, so let's quickly go to the coding screen, and we will fire the alerts, AI based alerts, I mean, using these all functions that I explained for generating the auto threshold by system. So, okay. Okay, so here are we on the coding screen, and this is the first AI based rule. The fraud records greater than equal to 5. It's okay. So, as I already told, I am using the model file, a generative AI model underscore n. So, this is for demonstration purpose. As I explained before, all the functions will be used And let me run this code. So it will initially, yeah, it will start from the beginning. So you can see here the bar is started, and it means the code has been executed. So yeah, records has been processed. You can see live. Oh wow, everything is live, running in front of you. You can see, and I will even explain it. You can see here. Wow, the mean probability. Sorry. Okay, let me go below again. So yeah, mean probability is 0.46, and standard deviation is 0.35, and mean median probability is 0.32, and standard upper quantile 0.91, as we explained. So processing with auto threshold of 0.81. You can plot the chart as well. You can see the distribution of probabilities. So this red line, this is the auto threshold generated by the system, and you can see that all the probabilities, high probabilities, are uh, ahead of that. So yeah, this is adjustment you have to made as per your business requirements. Okay, so yeah, wait a second, we will go to the email window as well. Okay, so here are we are in email window. These records can be fired. We just have to compare. You can see the fraud probabilities in the records. Fraud alert P1 generative AI generated for record greater than equal to 5, undetected Angola for Angola. You can see here uh, fraud probability, because the is lowest for the record is 0.83. And if I go back, you can see here processing with auto assigned threshold is 0.81%. So it should be above this. So for all alerts, because this is a single threshold based alert. So all alerts for this rule should have more than fraud probability of 81%. Here we checked. Here you can see 91 for all records for Bhutan. And if I go below, yeah, all is above 81. Let's check for Latvia premium rate. You can see 85. You okay? So for 85% of for every record, so it is above 81. So the alerts are being fired as per our logic. So wow, this is up to you. How you are how you are using these functions. And let me generate alerts for another fraud rule as well, AI based fraud rule, in live in front of you. Here is that code, and you can see here now it will run. So yeah, wow, it start running, and you can see here live records has been processed, and you can see here lower threshold 0.32 is too low, revising to minimum floor 0.70. This is some engineering I have done. So the lower threshold is quite low, so it has revised to 70. So I have created bins also. This is multiple threshold. So initial lower threshold is 70, as I have chosen. So middle threshold is based on I will show the code now. So here is the code. Middle threshold, these all are quantile based. I have put the 50 to 65, 65 to 87, and similarly above 87 as final, upper threshold. And you can see here now in the coding screen. So initial lower threshold was 0.70. Initial, I mean 30 from 32 was too low, so revised to 0.70. So initial lower threshold becomes 0.70%. Middle threshold become 85%. Upper threshold become 91% as per our quantile bins we have made. So single mode detected. Also I have put that condition. You can also put that condition as per your business requirement. See what happening is, I am checking the records as well. If some records are there between the lower and middle threshold, middle threshold is called threshold probability. So lower threshold and middle threshold, there are some records and they are greater than equal to 9, then we can use the mode function as well. So mode function, I told you that if there is a fraud probability that is being repeated in all records. So also I have sorted in the way that if there are multiple modes, then use the middle index. So revise the lower threshold to that. So what happened is, I will show you in the output screen. So the initial threshold was 70% for lower, middle was 85, upper threshold was 91. So single mode detected, mode value, single mode detected, that was 84%, because it has found some records between the lower and middle threshold. So it has revised the lower threshold to 84. But what happened is, post processing, it has checked that 84 of lower threshold has been revised is quite close to the middle threshold, so it doesn't make sense. So what it has printed, you can see, revised lower threshold is too close to the middle threshold, reverting to initial threshold, so it will go towards the 70, which was the initial lower threshold. So you can see here, processing with auto thresholds, final lower threshold 70%, final middle threshold 85%, final upper threshold 91%. Oh wow. And then we have the probability distribution chart as well, we will discuss this later. So if I go to the email window, you can see the alerts have been generated over the fraud records greater than equal to 5. So these are bins: low, medium, high. So if I go towards the low, it should be above, how much? This one, I mean 70%. 70%, they should not be below 70%. Let me check in front of you. So you can see here, wow, all have 84% something, for low, Angola. And similarly, medium, if we have go for medium, like Cuba, it should be over 85 but less than 91. Over 85, less than 91. Okay. Over 85, less than 91. Okay. Some records are 88, then 89, and then 89. So wow, great. It is also tested. The scenario has been tested successfully. Now upper threshold is 0.91, high for high. So the record for probabilities should be above this. Okay, let me go to the email window. For high, we check random, like for India, 91 or 100%. So it's greater than equal to 91, because I have given the condition greater than equal to also. I mean equal to also is there. So let's check for the Somalia, 100%. And if I check for Guinea Bissau, 99%. Okay. So it means that we have generated as per our scenarios and business requirements, and we have made single and multiple thresholds. Single threshold I have shown you already for this fraud rule first that we have had. So wow, here is the probability distribution also. I will explain both the plots after that, after this, I mean. Okay. Okay, so here I am in the default directory where those charts have been saved automatically with the alert generation. So let's go to the charts directly. So this is the first one, and let's open both first. Okay. So for this single threshold alert, as I have discussed earlier in previously slide as well. So here is the mean, that is yellow, and this is the median, this is purple line, upper quantile green one, and auto assigned threshold is 0.81, this is the red line. So you can see here also the major probabilities, higher probabilities are above that. So wow, I mean, so business requirement has been met, because we have auto assigned, and we are able to capture the higher probabilities. So this is something that you will learn when when you train your model, and you know your how your model is behaving through training and testing scores. and you become subject matter expert in that. And similarly, you can use these functions and revise the values also. So we can see the standard deviation range is also there. You can see here till from 81 till, if we go towards this one, I mean, point 11 value, I believe last time we were discussing. So okay, so this was for the single threshold. Let's go to the other another one as well, in which we have you multiple threshold. This is wow, wow. Here also we can see that lower threshold is 70. So for uh, three bins were there, low, medium, high. So for low, between 70 till 85, and from 85 till 91, medium bin, and then high bin is above 91. And even with these threshold also, we have covered the major probabilities, higher probabilities given by our model. So this was the very simple representation of auto threshold using these functions for AI based alerts. I will also show for the rule based alerts. But as per data science, you know that these mean, median, and mode are called measure of central tendencies that we have used, and we have used standard deviation and variance and range, that is called measure of dispersion, and quantiles are called quantiles. So I have covered the points that I have mentioned here: auto threshold, single or multiple auto threshold using mean, median, mode, standard deviation, quantile. Charlotte score, we will see that in our clustering reports. So AI ML based alerts, auto threshold, why use cases have been covered. Clustering reports, I have done high level engineering. We will use the Silotes score to generate auto reports, and we will also have rule based alerts in which we will use these functions also. Okay, so all other topics will be covered in second part, as this has already been a long video to explain all things. So what remaining is the clustering reports, and using Charlotte score, we have generated reports using auto thresholds. So what happened is, when reports will be generated, AI based model will also be in picture. And when these reports will be generated using auto threshold technique, so rule based alerts also will fire, and through the records of these rule based alerts, an AI model will be trained. So it will be a live scenario that from these reports, the rule based alerts will fire, and the record generated by those alerts, AI model will train itself for the new incoming file. For next time, whenever the file new record will come, so clustering model and AI model will come into picture. So this is also a very high level engineering. And then there is the last part, that high level artificial intelligence setup has been done, in which there is no functions of these auto thresholding will be used, like mean, median, mode, standard deviation, and quantile and all. What happened is, the system will be fed with call records and thresholds for the different fraud alerts, and system will itself learn from those records and threshold that next time the records will come, new records will come, then when to fire the alert. And also it will tell that the what is the fraud type, as per fraud pattern. So stay tuned for all this. And this is Akhil Singh Rawat now signing off. Please take care of yourself and have fun. Take care. Bye bye.